Hello everyone, this is Vani from Computer Science Department, PBC at the college. In these sessions, I'm going to share with you the performance of an algorithms. Where what is the algorithms means? In algorithms, we are defining an everything in step by step before we are doing an executions of an programs. So that means it is almost done the algorithms before we are executions. Even the algorithm is also defined or is can be abstract to that programs. So let us start to the performance of an algorithms. So performance of an algorithm is a process of making, evaluating, judgmenting about the algorithms, and it is predicting the resources which is required to an algorithms to peak perform it is a task. So there are the two types of algorithms defining is the space complexity and time complexity. So space complexities means analyzing of a space complexity of an algorithms or a programs is the amount of memory is needs to run a completions. So some of the reasons for the studying the space complexities are: if the programs is to run on a multiple users systems, it may require to specify the amount of memory to be allocated to the program. We may interested in to know in advance whether too sufficient memory is available to the run the program, and we have to know the one of third reasons which there may be a several possible solutions with the different space requirements. So fourth reason was it can be used to estimate the size of the largest problem that a problem can be solved. The space means needed by the program consists of the following complexes means instruction space and the data space. In the instruction space needed to the store the executable versions of a program, and it is the fixed. And second, data phase need to be stored the all the constants variables values has furtherly two components. Space needed by the constants and simple variables means this space was the fixed. Space needed by these fixed size structurally variables and structure arrays may be are the arrays and the structures, and dynamically allocates the space. This is the space usually as the variables. So that means the space complexity we should be defined that algorithms the how much amount of any memory to be need to run the completions. And now we are going to that each time of a function invoked the in the data structures is to be saved in the environmental stack has to be return the address. For example, from where it has to be resumed after completions of the call has a functions and values of the all leader variables and the values of in formals parameters in these functions has being invoked. That means it mainly we have to define that the how much space is to be required, and how variables and constants has to be needed by the space, and fixed sizes of the variable structures and how dynamically it was allocated. And now and how it is returns the address and values of the all leader variables, so it we are in the formally applied into that parameters. Where comes to the time complexity, the time complexity of an algorithms of an program is the amount of the time it needs to be run the completions. The extract time will be depend upon the implementation of an algorithm's programming language and optimizing these capabilities of the compiler user. The CPU with the speed and otherwise the characteristics are the specifications and so on. Now to measure the time complexity accurately, we have to count the all sort of operations performed in an algorithms. If you have to know this time for each of these primitive operations performed in a given computer, we can easily compute the time taken by the algorithm to compute the and these two executes. This time will from the mission to mission. By analyzing of an algorithm, it is hard to compute that extract time required and find out that extract completion complexity. We need to exact instructions to be executed by the hardware and the time requirement for the the instructions. The time complexity was also depends upon the amount of data needed imported to the algorithm, and we need to calculate the order of the magnitude for the time required. This is how the intentions to estimate that executions of an algorithm respective and other computations which will be used. So furtherly I want to be started, this is the time space complexity and the time complexity. So we already know that. So space was the recording to the was ways to be followed. Now again we have, now let us see the differences of an space complexity and the time complexity. Thirdly, so from comes to the definition, measures the, in the time complexity it measures the execution of a time of an algorithm to relate to the input size. Where come to the space complexity, it measures the memory usage, how the memory uses of an algorithm relate to the input sets. Time complexity defines the time of an algorithm, whereas comes to the space complexity defines the how much of the usage of memory is used. Where come to that, in a space complexity, the amount of memory, that means the RAM and algorithms required for an executions. Uh, where time complexity, amount of time and algorithms to be the takes, just it takes the times to be completed. Where in the space complexity we should be the efficiencies of the memory, terms of memory usages. Where in the analyzing of approaches in the time complexity, it a number of operations or computational steps are related to the input size. Where why we are importing size to defining the either the space complexity and time complexities means, in the in a space complexity the larger inputs may require this the memory for storing structures and or managing recursions. Where come to the time complexity, it input size impact on that, you larger inputs usually lead to the longer execution times. Where comes to the optimizations in the space complexity, minimizing the amount of memory needed for the data storages and processing, and reduce where in the time complexity it reduces the number of computational operations or the or steps. We have to optimize the, how to we reduce the, for example, we need to complete the task in a certain 10 minutes. In the time complexity, it should be calculated the every, we are doing the every step to be taken has some minutes or taken in that some seconds or the minutes. It should be reduces the time. That means the user can be done the processing either the in time complexity. Every time it calculates the time. That means we have to reduce the, even though in our software development sessions or any other real world applications, we already know that software applications or any other thing, we in algorithms way we have to define that reducing the number of computations operations to be steps, or in in a comparison to the space complexity, we have to minimizing the amount of uses of the memory usages. That means we have, if it is we cannot be minimized, it should be affected to our system. So that's why, for example, taking of an space complexity, we are creating a two dimensional of an array to n into n, it within the notations of an own notations of an n square space complexity. And we're taking of an a time complexity, we should be taken as a finding an element using a binary search of log of notation of log of an time complexity. So this is the space complexity and time complexity differences and performancing of an algorithms. So so once again I'm telling the performance of an algorithms means we are how the algorithms was working on the process, either in the either through the space complexity or the time complexity.